welcome to everybody. As Dundee Turkey Club, we will start a new series called A Step Into, in which we invite professors to introduce different disciplines in the neurofield. And in a couple of minutes, we will begin with our first field, neurophysiology, where Professor Laila Ayadhi will be talking about neurobiological aspects of autism spectrum disorders. So I'd like to hand over the word to Dilara now.
Thank you very much, Kaksu. Good morning, good afternoon, good evening to all who joined us from around the globe. First of all, I would like to extend a very warm welcome to our beloved brainies and friends from dandy clubs from all over the world who have joined us on this lovely evening and continuously show us their amazing support. Tonight, our beloved guest, Laila Ayadhi, is a professor and consultant of neurophysiology and the director of King Saud University Autism Research and Treatment Center, ARTC, who holds a bachelor degree of basic medical sciences from Kuwait University, is a graduate of medicine from the University of Glasgow, holds a PhD in neurophysiology, Leicester University, and has also a bachelor's honors hyperbaric medicine degree from Stellenbosch University. Professor Ayadhi is experienced in teaching, research collaboration, and consultation. She has over 22 years of research experience in the neurobiology of autism spectrum disorder, in addition to authoring and co-authoring over 167 publications and supervising over 24 master's and PhD dissertations. If you're ready now, Professor.
Thank you so much. Thank you, everybody. And thank you, Dilara, and thank you, Goksu, for the invitation. It's nice. What are you doing? So you are getting everybody everywhere. It's very, very beautiful what you are doing. I admire your work. So I will talk today. I will give you today very brief introduction about what we do in our Autism Research and Treatment Center. It's a summary of what we have been doing over the last years and how things, it's so good for young people to see how things progress from nothing, then from a small idea to something big. And it's always, if you have something in your mind, it will happen at one day. And when I saw you now, you triggered my memory back long time ago when I was a student, then new graduate, and how the aim, the whatever I aimed for came true. And I'm sure it will happen to all of you with hard work. So, yeah, enter screen. Okay. So you can see everything on the screen now?
Yes, Professor.
Okay, so I will talk about some of our neurobiological findings that we have been doing lately, over the last few years, about, to start with, long time ago with autism. So thank you, Dandy, again, Turkey, and Dandy everywhere. And this is the logo of our Autism Research and Treatment Center, and this is the logo for our Autism Research Chair, which come together with the Autism Center. We work together in parallel to each other. So I just want to say that whatever we presented in this, I will present in this presentation, all work have been done at the King Saud University Autism Research and Treatment Center. Patients, investigation, lab work, everything, diagnosis, all done locally here in Riyadh, Saudi Arabia, with local hands, of course. So this picture, I always use it in any presentation in my life since I started. When I started long time ago in 2002, but my research experience extends beyond that, but with autism 2002, my brain at that time was this picture reflect my brain. So things was not connected together. Everything things are not connected. I read a few things about language autism, adults in autism, risk factors, social, neurobiology, relationship, and it did not make any sense. So I was very much confused. I came across this picture, and then I thought maybe I will start here. somewhere where I can have my first step. So at that time, oxidative stress when I started, and I think now everybody knows that oxidative stress are highly reactive molecules. They have one electron on the outer orbit of these molecules, and they tend to change from a highly unstable reactive molecules to a stable molecule by acquiring or taking electron of whatever structure is surrounding them. Cell membrane, cell, blood vessels, whatever tissue. And once this oxygen is taken from the tissue will damage, and this highly reactive unstable molecule will become stable. Now, overproduction of oxygen-free radicals, it means that the local antioxidant, the natural local antioxidant system cannot cope, and they tend to take this extra electron from whatever tissue they are nearby, leading to tissue damage. So at that time, so antioxidant or oxidative free radicals, if it is not destroyed by the antioxidant, natural antioxidant system, it will lead to oxidative stress and then into tissue damage. So this is where I started my first few papers about autism. And at that time, I was working solo on my own, and I measured oxygen-free radicals production from polymorph nuclear leukocyte and whole blood in autistic children and compared to control. So the result came amazingly very significant. So this is the production of oxygen-free radicals with two different stimulants from whole blood and from polymorph nuclear leukocyte. And as you can see, this is the control, this is autism. As you can see, it is higher in autistic compared to control, okay? And the same, higher in autistic compared to control with another stimulant. Again, from the polymorph nucleoside with the two different stimulants again, it was higher in autistic compared to control. So then we came into conclusion that oxygen-free radicals is very high in autistic, and they could be under oxidative stress. In this paper, we measured only the oxygen-free radicals production. So the other paper came after that, where we measured the biomarkers related to oxidative stress to prove this point that it is very high. So the normal sense says that, it will direct us believing that those kids with high oxygen-free radical production, they will be under oxidative stress. So we did a lot of work after that. And as you can see, this is control autism. So autistic have lower antioxidant, vitamin E, vitamin C, glutathione. They have higher lipid peroxidase. So they are under oxidative stress. And so this is the non-enzymatic antioxidant, and this is the enzymatic antioxidant. And it is high again in autistic compared to control. So and then to make things a little bit complicated, I measured it was a solo paper as well. So I measured the sonic Hitchcock protein, brain-derived neurotrophic factor, and saw the relationship to the oxidative stress in that paper. Now, sonic Hitchcock is a neuroprotein proved to be playing role in present in the brain, in the thalamus, and in the lungs as well, in the thymus as well, and playing role in having possible protective effect in the body. Brain-derived neurotrophic factor is a neuroprotein as well with some neurotrophic properties controlling cell signaling, cell growth, axonal regeneration, cell survival, and other things. So in this paper, we measure those three: Hodgkin, brain-derived neurotrophic factor, and oxidative stress. And the result came very interesting. So serum level of sonic Hitchcock, it was significantly high in mild autism and significantly higher in severe autism. And this sonic Hitchcock protein was positively correlated to childhood autism rating scale. Is a scale where we measure the autism level. And at that time, we used to have a very nice Dr. Rana. She used to do all the psychological testing, and I am sending my regards to her, and we miss her very much in our center. So going from that, again, in the same paper, we found that brain-derived neurotrophic factor is higher in mild autism, but it is less in severe autism. So our conclusion, or my conclusion, I did that paper on my own. So I concluded, or I thought that sonic Hitchcock increased expression of the oxidative stress, the oxygen-free radicals lead to increased expression of sonic Hitchcock protein as protective mechanism. Again, brain-derived neurotrophic factor in mild autism could be increased as, again, protective mechanism in those kids, but in severe autism, the further increase in oxygen-free radicals could inhibit the production of brain-derived neurotrophic factor. So this was my explanation for the change and the up and down in the brain-derived neurotrophic factor. So the conclusion was that they are under oxidative stress, and they those kids with autism, they are under oxidative stress. So why? We need to know why. And then this led me again to this diagram and thinking the reasons. So I thought maybe I can start in some thinking about this area where there is autoimmunity, or the immune factor, or the inflammatory factor. So I extend the work into this area and this area. So we measured, and as you can see, early on in my life, I was working solo. Later on, the center became a center. I was on my own at that time, because nobody believed at that time, 2005, that there is some biological changes in their body. It is only in the brain, autism, but it is not. So we measured, or I measured, some pro-inflammatory cytokines, tumor necrosis factor alpha, interleukin 1, interleukin 6, and all came as significantly higher in autistic compared to control. Again, more neuroinflammation evidence came, and where we measured heat shock protein 70, transforming growth factor, and caspase, interferon gamma. All are proteins that play an important role in neuroinflammation and in as an immune modulator as well. So the result came that those inflammatory mediators higher, significantly higher in autistic compared to controls. All are significantly higher in autistic, the blue, compared to the red, the control. And then at that time, it was 2012, interleukin A was something new, one of the newly discovered interleukins, and we measured that one, interleukin 17A. Again, it's an immune modulator playing an important role in autoimmunity. Could be inflammation, and it could be. It was at that time classified as pro-inflammatory cytokine. We measure interleukin 17A, and it came as, so this is the level of interleukin 17A in healthy and in autistic. And it was high as the degree of autism high. So this is moderate autism, and this is severe autism. It was very encouraging results. So autism high compared to healthy, and mild compared to severe autism. And then we thought maybe we can prove the point of neuroinflammation and oxidative stress leading to immune inflammation through other biomarkers. We can't conclude from only one or two biomarkers. So in this paper, we measured the macrophage-derived chemokine and thymus activation-regulated chemokine. Both came, this is TARC, thymus activated regulated chemokine, high in autistic compared to healthy controls, and macrophage-derived chemokines, high in autistic compared to healthy, and both are positively correlated. This is another proof that there is a sort of degree of inflammation in their body. And so we thought, or is this increased oxidative stress and leading to neuroinflammation, leading to tissue damage? So we measured osteopontin. It's a neuronal damage marker, and it came that it is high. So now, as you can see, the pieces of the puzzle are coming together and in agreement together, and every time we do one paper, it will come in agreement or support the previous result, which encourage us to do more and to dig more in those areas that we are working in. So our conclusion at that stage that there is a level of inflammatory mediators. There is macrophage activation, there is T helper involvement, and there is tissue damage as well. So as you can see, this is another picture. So we proved the inflammation. We proved the oxidative stress from that picture that I showed you early on. And then now we are trying the next stage. We thought about why there is a neuroinflammation leading to tissue oxidative stress. Again, this picture. So then after finishing from this area and this area, we concentrated on this area. Is it the reason for whatever is going on? And so we measure some autoantibodies in their bodies, myelin basic protein in this paper, and it was very high. We measured anti-ganglioside autoantibodies, and we try to see if there is a relation to disease severity. So this is mild and this is severe. The level of anti-ganglioside M1 antibodies, it's an autobody directed against the ganglioside. And then to make things a little bit complicated, we try to see if there is any correlation between serotonin level, anti-myelin, basic protein autoantibodies, and the result came very interesting. Yes, they have higher level of serotonin, and serotonin is one of the neuromodulators and immune modulators, and the serotonin level was higher in severe compared to moderate, and those kids with autism, they have higher level of myelin basic protein, anti-myelin basic protein autoantibodies. So this is the healthy control. This is the autistic. It's very high, very highly significant, very clear. And it was positively correlated to the degree of autism. Then And at that time, there was this global interest in vitamin D. So we thought maybe we can find if this autoimmunity is again related to vitamin D. We measured vitamin D in autistic, comparing it to control. So vitamin D came as low in autistic. And we measured autoantibody, the MAG. It's the macrophage antibodies. I will try to remember the name. Macrophage. Yes, it's macrophage associated glycoprotein, I think. Yes. So the result came that we have autoantibodies against the protein high in autistic compared to control. And the higher, and it was a negatively correlation between vitamin D and this anti-autoantibodies against the MAG protein. So the higher the vitamin D, the lower the autoimmunity, and vice versa, proving again a degree of autoimmunity. And then we continued to work in this area, measuring more autoantibodies level in their body. And so we measured a neurokinin. It's a neuromodulator playing a role in autoimmunity, neuroinflammation, and another autoantibody. So we measured the autoantibody against the ribosomal B protein. And yes, this is serum neurokinin A. It was positively correlated to the degree of autism. And this is the neurokinin A with the autoantibodies against the ribosomal B protein. And there is a little bit degree of correlation. So this is a repetition. So we continued to prove our point, and we measured antimitochondrial antibody, and it was significantly high in autistic, again, compared to control. And then we concluded at that time that there is a significant level of autoimmunity in their body, leading to neuroinflammation. And this autoimmunity is the reason for the increased oxygen-free radicals production. And then I said to myself, I don't want to go all through the paper because there are huge amount of information. So I said to myself, now we have accumulating evidence, autoimmunity, neuroinflammation, increased oxygen-free radicals production. Maybe we are at this stage, we are ready to change from the investigating the reason to doing something, intervening, and intervention, try to help them. And this is where the camel milk research came. And why camel milk? Because it's locally accepted. It's part of our culture. It's loaded with antioxidant, low, it's very nice to drink, low cholesterol, no casein in it. The immunoglobulin in the camel milk are nanobodies. So those nanobodies, when we drink the milk, they don't need to be broken down to be absorbed. Our immunoglobulin and the cow milk immunoglobulins are micro. Are micro in size, so they need to be broken down to be absorbed. But the immunoglobulin in camel milk, they are nanoparticles. They don't need to be broken down to be absorbed, so they retain their biological activities when we drink camel milk. So we did the camel milk project, and it was one of the most interesting research project. It was a clinical trial. And we noticed, and we came across very interesting findings. So what we did, we divide them into 3 groups, and group, it's double-blinded, placebo, where they received cow milk, then group A, group B, where they received boiled and raw camel milk. Of course, we did all the checkups that the camel milk is okay and there is nothing wrong with it. So this is the psychologist that used to do the psychology work, and we miss her. She left us for a good reason. Okay, so what we did, we measured the antioxidant and we measured the behavioral benefit after the camel milk, 2 weeks of camel milk production, and the result came very nice. So this is raw milk, this is boiled milk, and this is placebo. So if you see, the glutathione increased with raw milk, and all are antioxidant and good things. And this is the boiled milk, higher increase in the glutathione, but no change in the placebo. Now, SOD, superoxide dismutase, a little bit high. It is, yeah, it is. It's not significant, but anyway, it is a little bit high. The same here, it's high.
Guess we're having a problem with the connection.
Where did we lose track here? Here?
Yes.
Hello?
Yeah.
Yes? Can you listen to me?
Yes, your voice is coming. Everything's fine now.
Okay. Do you want me to go ahead, continue, or stop?
Yes, please. You can continue.
Okay. So the antioxidant level was significantly high, and we published this paper. And then what did we find again? There was changes in the thymus-regulated activation, the chemokine. It's a neuro modulator. It's an inflammatory modulator, and it came that the inflammation significantly reduced in raw and boiled camel milk to compare to placebo. So we are having both positive effect on their blood in a lab work and on the scales aspect. So this is the behavioral checklist that we did, and it was this is the placebo. So there is no differences, no significant differences. But with the boiled camel milk, there was significant changes in their social communication and in their autistic mannerism behavior. Not all aspects improved, but 2 aspects are huge success in autism for those people who deal with autism all the time. Any change is a huge success in autism. And this is the raw milk. Again, significant changes in the social improvement in their social communication and in the social awareness. And it was a good success and good finding. So I don't want to take all your time. And so this is the story of our Autism Research and Treatment Center, where it started, as I said in the beginning, from a very simple question: what is it? Why? What is going on? I did the oxygen free radicals, then things progressed to bigger bigger and bigger work until we are now aware or having an idea what's wrong with them. And we are trying to help them through other things. Of course, this is a very brief explanation of what we do or what we reached so far in our Autism Research Center. This is one autistic child having auditory integration therapy. It was an intervention that we did some times ago, and it proved to be very effective and improving their perception through good hearing. And we repeated that project twice because it was very beneficial for them. And we produced 3 more papers in addition to that one, proving the beneficial effect of auditory integration training. These are some of our kids that they agreed to share their pictures with us. And this is Noura. She is now very old young lady, not very old, sorry, she's now mature young lady. This picture was taken in 2011. So she's a grown-up young lady now, doing very well. And what we do in addition to our research in the lab, we do annual awareness campaign where our medical students participate, try to explain things for the public about autism. Now all are graduate, maybe in the United States now or in Canada doing their postgraduate study, or in Saudi Arabia as well. And we try to increase public awareness through nice things. So this is a video game where everybody, as you can see, interested in this video game that Muhammad is doing. And I'd like to thank all children and parents who participated always in our studies, and to King Abdulaziz, City for Science and Technology, for funding our project, and the National Plan for Science and Technology for funding our project. And thank you, Dandy Turkey and Dandy Worldwide for this opportunity. And if you want to ask any question, I'm open for any questions, and thank you.
Thank you so much, Professor. We appreciate you taking your time and arranging this lecture. It was a very informative and intriguing presentation.
Thank you. It was very summarized because we had so many papers. I can't present all of them, but these are making sense together. So thank you for listening to me.
Now we can take questions from all the participants. Feel free to write them into the chat box, or if you like, you can unmute yourselves and ask away.
Actually, I have a question, if you would like to accept.
Yes.
So I would like to ask a question regarding the elevated pro-inflammatory cytokine levels.
Yes.
So you mentioned they were elevated, so I would like to learn if some kind of immunosuppressant therapy or treatment is being applied to these patients, or what kind of treatment is being used.
Yes, yeah. There is some initiatives in some specialized center to use immune therapy as an intervention method. It's very risky, of course, and it's very expensive. But if it is done in the right place with the right people, it is successful. Maybe the neurobiological basis of autism in our kids in Saudi Arabia are a little bit different from any other countries, because genetically we are different from any other countries. So those findings are, I can't generalize these findings, but I can say that our kids that we examined manifested, and we documented whatever we documented on those group of kids. But yes, there is some centers in the United States and in Europe are doing immune intervention. Sometimes it is successful. Yes.
Thank you, Professor.
Thank you.
If no one else has a question, I would like to ask you one, Professor. I would like to know what made you get into the field of autism and how you keep your patients when dealing with them, because they're a difficult group. They need lots of patience and they need lots of care. So it's really nice to find a whole center that takes care of that. I would like to know what keeps you.
It's a very interesting question. When I was 11 years old, I watched a movie about autistic child, and it was very puzzling to me, and I didn't know what is that. And then what I took from that movie, the word autism, and that's it. Then when I studied medicine, when I went to the pediatrics, I was waiting for this piece, for this part of the curriculum to know about autism, but nobody taught us anything about it. So when I finished my final, I opened my pediatrics textbook and trying to search where is autism, and it was this big paragraph, 4 sentence. It's a neurodevelopmental disorder with unknown etiology, with unknown treatment, and that's it. So I think now this is maybe it's a subconscious hidden reason for me searching in that one without meaning to do it, but it came because it's in my mind. They are very difficult to deal with, but if you know them, you know how to deal with them. They are lovely. They can't communicate, but they understand you. You give them order, you treat them normal, they behave the way you want. It's not difficult for us at all to deal with them.
Thank you very much. I believe it's the thing that they're mainly misunderstood.
It's a communication gap, exactly. There is, I think, a question about as a data recommendation in your patient. Yes, yeah. After the study, it's Daniel that asking this question. Have you implemented that milk as a dietary recommendation on your patients? I mean, how much you have to drink and how easy is it for them to get it? Yes. So after the publication and the conclusion, we make a recommendation that it's a good dietary food. Try to incorporate and include it in your diet as much as you can. And those who started the project with us continue to have it. It's not easy to get camel milk in Saudi Arabia, although it's available, but it's not available. It's available only in selected organic supermarkets, and when it is there, it will finish immediately. It's quite difficult, but they drink it and people like it, and it's a very healthy option to have camel milk.
Any other questions?
Thank you, Daniel.
I think.
Okay, so that's it, I think.
Yeah. If there are no more questions, I'd like to thank you, Professor, again on behalf of all for the great lecture. Also, thank you to everyone who saved us a place in their schedules and stayed till.
Daniel is asking another question. He's very interested in camel milk. Have you tried to isolate the active components present in camel milk? Or is it too expensive? It's not expensive, Daniel. No, it's not expensive, but it is not available. So what people do, they go to special farms where they bring a huge amount of camel milk, and freezing this camel milk minus 20, it will not, the camel milk will not lose its activity. so they can freeze it. We did not isolate the active component because this is done at the nutrition department, and it's already done, and there is a lot of publication regarding that one. Thank you. Okay.
Should we give it 1-2 minutes? Anyone has any questions?
You can unmute yourselves.
Yeah, I have a question, Professor. Did you try maybe another types of milk? I heard that the goat milk is quite high in with antioxidants, and it's more like available.
It's I did not try the goat milk. Yes, you are right, but well, you know, camel is this big and goat is this, and camel produce this much milk. The goat produce this much milk. So for us, it's quite rare to have goat milk. I didn't do that one, no. But the immunoglobulin, which we are targeting in the camel milk, are the thing. So camel milk have nano immunoglobulin. Goat milk doesn't have nano immunoglobulin, and cow milk. So whatever, personally speaking, did the effect is not only the antioxidant available in the camel milk, it's only the, and it's in addition, it's the immunoglobulin that it is nano, doesn't need to be broken down, it will be absorbed, retaining its activity, giving a good effect in the body. So this is the reason for having camel milk.
Mm-hmm.
Yeah.
Thank you.
And camel milk is a very good dietary intervention or food. It have anti-diabetic effect for those who have diabetes. The insulin in the camel milk, again, it's a different structure and it doesn't need to be broken to be absorbed. So it will absorb and retaining its activity. So, and I tried it on myself, eating, not having my anti-diabetic medication, drinking camel milk. My blood sugar did not go up because I had the insulin, the natural insulin from the camel milk, which it is not to be broken, to be absorbed. It is retaining its activity. So it's a good thing. It's a good food. It's very nice, good food, the camel milk. Yeah, thank you. Okay. Thank you, Julian. Thank you, Daniel. Yeah.
So I think there's no more questions.
Okay, thank you so much and good luck for everybody. And thank
So
you for the
before-
invitation.
Thank you so much.
Thanks a lot.
Very nice. Thank you for helping us uncover, even if slightly, a part of autism. I believe we've been taking a recording for this session, so if it's okay with you, we would love to share it on YouTube.
Yeah.
If it's okay.
Yes, yeah, of course, yeah.
Thank you for all for saving us a seat in their schedules. We would love to have you again with us in our upcoming events. Alpiran, I leave the stage to you.
Thank you. Have a nice day, everybody. Thank you.
So we really value feedback in the feedback. So in the chat box, you will find the feedback form of the event that we would really appreciate you filling out. And we are not done yet. The fun continues. We have prepared a small Kahoot activity, nothing complicated, something for fun, everyone to engage. So for those who would like to participate, the pin is in the chat box. Please don't hesitate to reach out regarding any questions that you might have. Stay safe. Don't forget to fill out our Dandy Body form and follow us on our social media platforms to stay up to date. Hope to see you at our upcoming events.
Thank you.
Bye-bye.
Thank you again, Professor.
If you want to participate, yeah, you can stay in this link and we can start.